Hello everyone, welcome to next Selenium training tutorial video. This is next video in the series of Java 8 and Selenium WebDriver. And this is part 6 in the series, and we would continue to see some more stream operations in this series of the video. And if you are new to Java as well as Selenium, then please do not start here. I'm going to link my previous training sessions on the description of the video, so please start there. Now let's see what we would have learned by the time we are done with these training sessions. Then in this training session, we would see different ways of creating a stream, like empty stream, stream of collection, stream of string objects using builder. We would also see generate method and iterate method. We would see a stream of primitive like integer, which we had seen in past as well, and long and double. They are created using something called integer stream, long stream, and double stream interfaces. We will see stream of file. This is also we have seen in the previous session. We will see why streams cannot be reused and how we can eliminate expensive stream operations, about the parallel stream, and at the end we would see WebDriver example. So let's start with the different ways of creating stream. So I've created a new class here from on the project I have on GitHub, which I'm also going to link on description of this video. And this is stream miscellaneous 2. So while creating a stream, we have different ways of creating or setting up a stream. When we declare a stream, we can do as a stream.empty, which would set up, well, obviously empty stream. So this is the string stream of type string, which is actually empty. So there's nothing here. We had also seen in previous sessions with Selenium WebDriver that when we have a list or a collection, then we can just invoke something called stream API over the collection, and then this would give us a stream. For example, we have seen that we can get all of the link elements on a page and then get the stream of web element objects using the stream API on the collection. Since I have explained this earlier also, I will not get into much details here. Now let's see stream of string objects. A stream of string object can be created using two different ways. We can either use auth API on the stream and then pass on the string parameters with which we want to create a stream. And this is what I have done here with string stream1. This is going to create stream of string objects A, B, and C. And we can also use stream API from arrays. So this API was added on arrays class on Java 1.8, and this takes, as you see here, array of type T, and in our case we are passing array of type string. So we declared a string array here containing A, B, C, and then using arrays.stream we can create stream of a string object. We can also create a stream of string objects using a stream builder. So what we have to do here is we have to call the builder API and then add different string objects using add methods like I'm doing here, add A, add B, add C, and in the end we can call the build method. We have seen builder pattern in one of my previous training session, and if you do not know what is builder pattern, then I'm also going to link that to the description of this video. One thing to note here is that I have to specify the string type here, as in the object type here on the right hand side, because if I do not specify this, then what we get from build is going to be an object. So if I don't specify this, and if you see here, we get stream of object, and we have an exception here because, you know, on right hand side we have object, and on the left hand side we are expecting a stream of string, and this is the reason we have to specify the object type here as string. Then there is a method called generate. Let me bring this to life. And using generate method also we can generate a stream. What I'm doing here is I'm creating another stream of string objects, and I have invoked generate method on the stream API. Now let's see what generate method does. Generate method takes a supplier argument, and you may have guessed it by now that supplier is a functional interface, which is right over here. And if I go to its definition, this functional interface has one abstract method, which is get, and it returns the result. It does not take any argument. Hence, if you see the declaration here of generate, I have empty parenthesis because supplier does not take any argument. On the right hand side of the arrow I have implementation, which is nothing but I'm filling in my stream with the letter A. In the end, I have limited the stream using limit API with size 5. Now, the point to note here is that the generate API is going to generate infinite stream, and this is the reason we have to limit it. If we don't limit it, then the program would keep running and you would run out of memory. And if I execute this program now, we would see that A being printed 5 times because this is string of stream. Now this stream of string objects is going to contain API A, letter A 5 times. So let me run it. Now you see here A is printed 5 times. Next, what we have, let me comment this and let's see the next API, which is the iterate method. Iterate method is also another way of generating a stream. Here I am creating a stream of type integer object and I have invoked iterate API, and this is also being using limit API because we end up with infinite stream with iterate method as well as with the generate method. Now let's see the argument of iterate method. As argument of iterate method, we have 2 parameters here. One is the integer, and this is named as seed, and the unary operator. Let's see what are these arguments doing here. So what is seed? Seed is actually nothing but the initial value. So in our case, the initial value is 2, and then the unary operator, which you may have guessed again that this is going to be functional interface. So this functional interface, well, we don't see any abstract method here, but since it extends function and we know that function is a functional interface with abstract method applies, so unary operator also becomes a functional interface because it is not implementing the abstract method from function interface, hence apply method is available to unary operator as well. And as we know that apply takes 1 argument and returns the resultant after applying the function on the given argument. So if I go back to our statement here, I have a stream.iterate 2, which is the seed, which is the initial value, and the function. And what is the function here? Function is I'm multiplying the initial value seed by 2 and then I limit it by 5. So when I run this, we would see 5 different values being printed, beginning from 2 till 2 multiplied by 2, 4, 4 multiplied by 2, 8, 8 multiplied by 2, 16, and then in the end 32. Let's run it. Yes, we have 2, 4, 8, 16, and 32 being printed 5 times because we are limiting it by 5. Let's see what we have next. Next, we have a stream of primitives, integer stream. We have seen integer stream in previous sessions, so I would not pay much attention to this. We saw that we can create integer stream by calling range method on the integer stream. We also know that this is first index inclusive, second exclusive. So there's a different method here called range closed, which could be used to also involve the second argument in the range using which a stream is being created. Now on the similar lines, we can create long stream. Long stream could also be created using range or range closed method. No rocket science here. And then we have something called double stream. Let's see how we are initializing a double stream here. So double stream can be created using doubles method on the random class. Doubles method was added on Java 1.8, and what it does is it gives us a stream of given size, and the size is something which is being passed as 3 here. But what doubles we are going to get? What doubles we are going to get are the values between 0 and 1. So if you see the API definition, it says it returns a stream producing the given number of values, pseudo-random values between 0 and 1. So if I run this program, we would get 3 double values printed between 0 and 1. Let me execute it. So we have 0.1, 0.7, and 0.7 3 printed again, and if I run it, we will again get 3 random double values between 0 and 1, which would hopefully be different than what we are seeing here right now. Yep, so 0 0.2, 0 0.7, 0 0.9, if I run it again, 0 0.6, 0 0.3, 0 0.4, so we keep getting different random double values on each run. Let's see what we have next. Next we have stream using file, and this is something which we had also seen in exact last session, so I would not pay much attention to this. We know that we can create a stream using something called files.lines, and then we can pass the argument as in file path to it, and then we have each line being stored as a string value in the stream. The difference here is that I have also specified the character set as UTF-8, and in the end we close the stream to avoid memory leakages. Next, let's see why we cannot reuse the stream. So let me bring this section to life, and what we have here is quite simple. We created a stream of a string object using the stream.off. We saw this earlier, and then we filtered the elements. We get only those elements which contain letter B. And now this stream is being exercised twice here. So what we do first we get first element using find first, and we had seen this before that find first gets an optional, hence it is assigned to an option called first string. And then we are again using the stream to get any element, and this is the problem here, because what happens is once we have exercised the stream, this stream would not be available to be used again, and we would receive an exception. So if you do this operation yourself, you would have illegal state exception. Let me run it. You see, we get exception, which is illegal state exception. It says the stream has already been operated upon or closed. And this is true because we have operated on this stream by calling the terminal operator find first. We had discussed intermediary and terminal operations in previous session. So once we have called the terminal operation, this stream is not available anymore. Now what we can do to correct this, well, you may have guessed this. What we did in past was we were collecting a stream in a different collection, and this how we were exercising our stream more than once, and this is the same thing which we would do here. So the logic remains same. Create get a stream of string objects. I have updated the string objects here. Filter it on string elements which contain letter B, and then we collect it using collect API. We have used collect API many times. So we collect it into a list using collect collectors.toList, and this is the list of string elements. And now what we can do is we can invoke those different operations using a stream out of this list, and this time we will not have any illegal state exceptions. So for example, I can do elements dot stream dot find any, it goes to an optional, and then I print it. So how I print it, I say any element, if present, then print it. We have seen if present in past, which is going to carry out the operation on the elements in optional if they are available. So print would be carried out here. In the similar way, we get another optional here, which is first element by invoking stream again on elements here, and then we call find first. So if I run this, we would not have any exception this time. You see? So remember, if you end up with the use case of needing to use stream more than once, then collect it in a collection and then carry out more operations on the collection. And last, remember one thing, which operation goes there. So the rule is that if you are reducing the size of the stream, then they should come first. For example, if you use filter or skip, which we will see later on, if you are using them, then they should be used before you apply a terminal operation, because well, not terminal operation. In general, if you are using any of the intermediary operations which are going to reduce the size of the stream, then they should come on the top of the stream operation. Because if you are applying, for example, map on a stream first, which is going to transform the value of stream elements to something else, and then you apply filter on it, then what would happen is that you may end up in a situation wherein filter is applied on on a stream which actually would be unnecessary. For example, if I apply map on set of string objects to add some extra letters to a stream which contains a string, and later on I apply filter to remove string objects which do not contain a specific letter, then map was unnecessary because the filter is going to reduce the size of the string. So apply filter, distinct, skip, etc. before you apply operations like map. All right, then what we have next here, parallel stream. So this time I have a homework for you. So do some analysis, do some research, and carry out some examples using parallel stream and see how that works and how it is different from the normal stream. Now let's jump on to the WebDriver examples. So what I have here is I created another class here called Selenium WebDriver. It's session 6, and I have changed lots of different operations here with stream. We are going to continue to use the registration page like in previous sessions, and we have registration page object created here. Registration page would be launched here. We accept cookie here, and then what we are doing here is we get all of the links on the registration page. Then this gives us a list of web elements. Then we stream it, so we get a stream of web element. Then what we are doing is we get text of all of these elements, and then we convert them into lowercase. So we know that we can do transformation using map. So I apply map here. Map has function. Map takes function as an argument, which is a functional interface, which we saw before has apply method, which takes one argument, applies function on this, and returns the resultant. Hence, the argument goes on the left-hand side, and the implementation is here on the right-hand side, which is nothing but get the text and convert this to a lowercase. And then what we are doing is we are skipping first 10 elements. How we do that? We are using a skip API here. So we have not seen a skip before. So let me explain you what a skip takes. It takes argument as in the number to which the stream is to be skipped. So if you see its definition, skip, it says number of leading elements to skip. It's very simple API. And in the end, we are collecting it to a list called required first list using collectors.tool. It's simple. Get all the links, stream, transform them, as in get the text and convert them into lowercase, skip first 10 elements, and then collect it to a list. In the end, this spelling is wrong. Yes. In the end, we are printing the size of the list, and then we are printing each element using what? Well, you may have guessed it, for each, and then system.out.println, which is method reference we have seen in past as well. Let me run it. Let me change the configuration to use testng file, and let me execute this. So we have our registration page being launched, and links are collected, and operation is over. Let's see what is printed here. So this is our first print statement. We have list which is of size 141 and 10 are skipped, so it was actually 151, but we are dealing only with 141, and then it goes on printing text element of all of the elements in this list. Now we have some empty space, so looks like there are some links which do not have any text whatsoever, and then it prints some text which is available with some links, like one link has December 1st 2015, another link has text STF test, and so on. Then again some empty links, no text, and yeah, in the end we have a link with the text called Powered by Blogger, the platform I'm using for blogging. Now let us modify this list and let us remove these empty links which do not have any text. And we know that we cannot reuse the stream reference. So we have access to the list collection here, and we can exercise this. So let me comment out this part. And what we do here is using required list element, the list which we get from the previous set of statement, we get a stream again, and then we apply filter. Why we apply filter? Because we want to get rid of all of the link elements which do not contain any text. So we know that filter takes a predicate on which we can test under certain condition, and the condition here is that, well, list text, well, not the list text, the link text should be empty, which means length of the link text should be greater than 0. So if it is not empty, then we create another stream out of all of our link elements, and then again we collect it to a list using collectors.toList, and this is our new list. And then what we are doing is we are printing the size here using remaining list elements.size, and then we print each element using for each API. So what we did here was we filtered out all of the link elements whose length is greater than 0. So we create another stream with only those links which have got text. So let me run it. I cannot comment this part because we need this element. Okay, no problem. Let's run it. So the browser is being launched and stream operations are being performed, and over. Let's see outcome. So the previous outcome was 141, we know this, and then some list elements are printed here, and then yep, so this is our next print statement, this one, and then we have next size being printed. So we have only 14 link elements which have got some text, so we get 14 here, and then we have all of these text elements being printed. So these are those 14 links till here. All right, let's modify it furthermore. Let's try to filter those link elements which have got certain text, and this is what is happening on the next set of a statement. So let me comment this out. And now what we do, we start our exercise from the list from the previous set of statements, which is remaining list elements, the list which contains the elements which have got some link text, and then you may have guessed it again that we have to apply another filter to get another set of stream which contain specific text. So what we do here, get remaining list elements dot stream to get the stream, then filter it again those web elements, no, not web elements, against those string elements which contain the word more. And then as usual we are collecting this to a list. So this is our new list, links with more, which is list of string elements containing only those elements containing word more. And then what we do, we print the size here, and in the end we apply for each method to print the individual values. So let's see what happens when we run this. Browser is launched, stream operations are being performed, and done. So this was our first operation, 141, and we know from here somewhere down we have second operation. Yes, this is the one which takes 14, which has 14 elements, and in the end what we did another filtering with getting only those elements which contain word more, and then creating a list out of this. And we can see from here we have 1, 2, 3 instances where we have word more. So this is the last print statement linked with word more, which is right here. So size is 3, and all of these 3 string elements are printed here. So this was another exercise with some more stream operation, filtering, mapping, capturing them in collection, trying to reuse the stream by storing previous stream operation in a collection and then carrying out further filtering operations on them. So remember, as I said before, that if you want to reuse the stream, then you will have to store it somewhere, because we cannot carry out more operations on the stream once we have done the terminal operation. All right, anything else left for this session? Well, this was all pretty short session, and I hope you found something interesting and you learned something new. And if so, then please hit the like button and stay safe, and I would meet you in next session. Bye bye.